Welcome to the Funeral Channel Network's latest deep dive. I'm really glad you could join us today because we are getting into something that, well, it touches so many lives, but it's often totally misunderstood.
Yeah, misunderstood is definitely the right word for it.
Right. So imagine fighting a war where the enemy isn't like an invading army, but the actual factories producing your own soldiers. That is the paradoxical, terrifying reality of leukemia.
It really is. It turns the body's own defenses against itself.
Exactly. And when we see an orange awareness ribbon, pinned to a lapel or tied around a tree, it's so easy to just acknowledge it as a symbol for a good cause and just kind of move on.
Oh, absolutely. We see ribbons all the time and just filter them out.
But that specific color, the orange, it was actually chosen for a reason. It represents energy, strength, and this almost, a defiant determination. And when you look at the source material we are diving into today, which is an excerpt from Leukemia Awareness, The Power of the Orange Ribbon, you realize that determination isn't just some marketing buzzword.
No, it's really not. It's a fundamental requirement.
Right. It's a biological and psychological prerequisite for facing a cancer that completely rewrites the rules of engagement. So our mission today is to move past the simple visual of the awareness ribbon.
We really need to unpack the profound scientific realities hiding behind that piece of orange fabric, right?
Yeah, exactly.
Yeah.
We're going to explore the paradigm-shifting treatments that have completely redefined modern medicine and look at the deeply human stories of resilience and memorialization connected to this fight.
Which is so crucial.
Yeah.
Because to really understand leukemia, you have to totally recalibrate how you conceptualize illness.
How so? Like, what's the fundamental shift?
Well, most people, when they hear the word cancer, they immediately picture a solid mass, right?
Yeah, like a lump or a tumor.
Exactly. The mental model is highly localized.
Mhm.
It's, a lump in the breast, a nodule in the lung, a dark spot on an MRI. But leukemia fundamentally shatters that mental model. It strips away the whole concept of localization entirely.
Okay, let's unpack this. Because the leap from a solid tumor to a blood cancer is where where a lot of the baseline understanding gets kind of muddy for people.
It does. It's a huge conceptual leap.
Right. We're talking about a disease that originates deep inside the bone marrow. And I want to try to move away from those old, overly simplistic analogies of like the body being a city and the marrow being a factory.
Right, the typical textbook stuff.
Yeah, imagine the bone marrow is the body's central manufacturing plant for essential emergency workers. If that factory gets taken over by bad actors, the city doesn't just have a localized problem in one building.
No, the whole infrastructure collapses.
Suddenly there's no one to fight fires, which would be infections. There's no one to deliver supplies, like oxygen, and no one to do repairs to control bleeding. So from a biological perspective, what is actually happening in the marrow microenvironment when leukemia takes root?
So to really understand it, you have to look at hematopoiesis.
Which is the blood cell creation process,
Yeah,
right?
exactly. It's the process by which your body creates new blood cells. Inside your bone marrow, you have these things called pluripotent stem cells.
Pluripotent,
Yeah,
meaning they can become anything.
right. They're essentially blank slates.
Hmm.
Under normal conditions, they follow this highly regulated biological algorithm. They differentiate into two main lineages, the myeloid and the lymphoid.
Okay, so they split into two distinct family trees.
Yes, and from there, they mature into your red blood cells, your platelets, and your various white blood cells. It's this incredibly elegant, beautifully balanced
Yeah,
system.
a highly regulated differentiation process.
Exactly. But leukemia is essentially a total corruption of that biological algorithm. A genetic mutation occurs in just one of these early progenitor cells. And mutation does two devastating things simultaneously.
Okay, what's the first one?
First, it arrests the cell's development. So the cell gets stuck in this immature, totally non-functional state. We call these blast cells, or blasts.
So they're basically stuck as teenagers and refuse to grow up and do their jobs.
That's actually a great way to put it. And second, it turns off the cell's apoptosis mechanism.
Apoptosis, that's programmed cell death, right?
Yes, normal cells are programmed to die off when they get old or damaged, but these blasts don't. So now you have these immature, useless blast cells that refuse to die, and they just start proliferating wildly.
Oh, wow. So they are essentially outcompeting all the healthy cells for resources.
Exactly. They take over completely.
It's not just that they are bad cells, it's an evolutionary dead end that just crowds out the marrow. The marrow becomes so packed with these blast cells that there's no physical or metabolic space left to produce the functional cells the body actually needs to survive.
And what's fascinating here is how that specific microenvironmental failure triggers a massive systemic catastrophe.
Because it's not contained.
Right. Because there's no solid tumor, you can't just go in and surgically excise it. From the exact moment the disease manifests, it is systemic.
It's everywhere.
Yes. The corrupted cells are flushed out into the bloodstream, flowing through the very lifeblood of the patient. The cancer is literally the transport system itself.
Man, that distinction that the transport system is the cancer is chilling. The psychological toll of that reality has to be immense for anyone facing it.
Oh, it's completely overwhelming.
You aren't fighting an enemy that has set up camp in your left lung. You are fighting an enemy that is coursing through your brain, your heart, your extremities. It is everywhere and nowhere all at once.
And that's why the orange ribbon is so deeply necessary. It symbolizes the determination needed to fight something so pervasive.
Yeah, that determination makes total sense now. And that systemic failure, it explains the downstream physiological collapse, doesn't it?
It does. It maps perfectly to the symptoms.
Like if your marrow stops producing red blood cells, you become profoundly anemic. You have no energy because you physically can't transport oxygen.
Right. And if you stop producing functional white blood cells, your immune system crashes.
And platelets, too. If you stop producing those, you lose the ability to coagulate blood, leading to severe hemorrhaging or easy bruising.
Exactly. And that cascade of failures brings us to a crucial point about how it's diagnosed. Because the disease manifests as the degradation of normal bodily functions, it doesn't present with, like, a glaring neon sign.
It's not a sudden lump you find in the shower.
No, it presents as a slow accumulation of really subtle deficits.
And that leads directly to the sheer daunting scope of the disease, which is categorized into four main types. We're looking at acute lymphoblastic leukemia, or AL, acute myeloid leukemia, which is AML, chronic lymphocytic leukemia, CLL, and chronic myeloid leukemia, CML.
Right, the four distinct phases of the disease.
But before we break down the biology of those four phases, I actually have to push back a little on the symptomology that's presented in these widespread awareness campaigns.
Okay, go ahead. What's the friction point for you there?
Well, the symptoms consistently listed are things like fatigue, frequent infections, easy bruising or bleeding, bone or joint pain, and unexplained weight loss.
Yeah, those are the standard warning signs.
No, I completely understand the clinical accuracy of that list, but fatigue, joint pain, I mean, these are incredibly common human experiences.
Yeah.
If I work a 60-hour week and help a friend move couches on the weekend, I have fatigue and joint pain. My concern is, how do we prevent people from falling into an information overload panic, like Googling their symptoms and assuming a random bruise is a systemic blood cancer, while still ensuring they don't ignore legitimate warning signs?
That is a completely valid critique of how medical information is consumed in the digital age. It's a real problem.
Right. Because WebMD will tell you everything is cancer.
Exactly. And this raises an important question about the functional utility of awareness campaigns overall. The goal of the orange ribbon and pushing out this symptom list isn't to turn the general public into hypochondriacs who self-diagnose based on a single variable.
Okay, so what is the actual goal then?
The goal is pattern recognition. Because early diagnosis is inherently challenging with these vague symptoms, the campaign serves to prompt timely medical evaluation rather than assuming it's just a bug.
So it's about the clustering of symptoms, not the isolation of one.
Precisely. If you are fatigued, well, that is life. But if you are experiencing bone-crushing fatigue that remains unresolved after weeks of rest...
Like, sleep doesn't fix it.
Right. And then that's accompanied by petechia, which are those tiny pinpoint red or purple spots on the skin caused by bleeding capillaries.
Oh, I've seen pictures of that. It looks like a rash almost.
Yeah, it does. And if on top of that, you are suddenly spiking fevers with no clear viral cause, that is a cluster.
That's a pattern that shouldn't be ignored.
Exactly. The awareness campaign serves to lower the psychological barrier to seeking clinical evaluation. We want to shift the internal monologue from, oh, I'm just getting older, to this pattern deviates from my baseline. I need to get checked out.
Which is usually just a simple, highly accessible blood draw, right? You aren't asking them to demand a bone marrow biopsy on day one. Just go get a CBC, a complete blood count, to check the actual numbers of those red, white, and platelet cells.
Right. And that early clinical intervention is vital because, as you mentioned, leukemia isn't just one disease. Those four main types we talked about dictate entirely different clinical trajectories.
Okay, let's break those down. The terminology here is highly specific, right?
Yes. So acute means the disease involves those highly immature blast cells we discussed earlier, and it progresses incredibly fast.
Like aggressively fast.
Very. Without immediate intervention, acute leukemias can be fatal in weeks or even months.
Wow. And then chronic is the opposite.
Right. Chronic means the cells are partially mature. They might actually function somewhat normally for a period, and the disease progression is much, much slower.
Mm.
It can sometimes play out over years before the symptoms become severe.
Okay, and then you have the lymphoblastic versus myeloid distinction.
Yeah.
That goes back to that early differentiation in the bone marrow we talked about, right? The family trees.
Exactly. It's about where the corrupted cells originate.
So are they in the lymphoid lineage, the ones that are supposed to become your B cells and T cells, which are kind of the specialized assassins of your immune system?
Yes. Or are they in the myeloid lineage, which produces your oxygen-carrying red blood cells and your first responder white blood cells, like neutrophils?
So if we connect this to the bigger picture, you start to see why the demographic spread of this disease is so universally devastating. It doesn't discriminate.
It really doesn't. Acute lymphoblastic leukemia, or AL, is actually the most common cancer in children and teens.
Which is just heartbreaking.
It is. It strikes when the lymphoid system is in its most active developmental phase.
Mm.
But conversely, chronic lymphocytic leukemia, CLL, is almost exclusively a disease of older adults.
So the cellular mechanics of the corruption change depending on the age and the specific microenvironment of the patient.
Precisely. It's incredibly complex.
And the fact that a single disease category spans from toddlers to nonagenarians means the infrastructural support required is just dizzying.
Oh, the support systems have to be incredibly diverse.
Right. You have pediatric oncology wards dealing with the developmental psychology of a 5-year-old facing mortality. And simultaneously, you have geriatric oncologists managing a 75-year-old whose leukemia treatment has to be balanced against pre-existing conditions like heart disease or diabetes.
Exactly. You can't just throw a universal leukemia protocol at the wall and hope it sticks.
You absolutely cannot. And that targeted necessity is exactly what drove the most profound medical revolution of the last half-century.
Yes, the transition from crude, blunt force trauma treatments to hyper-specific biological interventions.
Here's where it gets really interesting for me. Because when we talk about the history of cancer treatment, specifically traditional chemotherapy and radiation, the old metaphor was carpet bombing.
That's a very accurate way to describe it.
You pour a toxic compound into the body that attacks rapidly dividing cells, and you basically just hope the cancer dies before the patient does.
It's effective, yes, but the collateral damage is massive.
Right. The damage to healthy, rapidly dividing cells like hair follicles, the mucosal lining of the stomach, healthy bone marrow, it's catastrophic. But the newer advancements, the targeted therapies and immunotherapies we're seeing now, they operate on a completely different philosophical and biological level.
They do. They represent a massive paradigm shift from broad cytotoxicity to precise molecular manipulation. Let's look at targeted therapies first.
Okay, lay it out for us.
The quintessential triumph in this field was the development of tyrosine kinase inhibitors, specifically for chronic myeloid leukemia, or CML.
Which used to be essentially a death sentence, right?
For decades, yes.
Mm-hmm.
The researchers discovered that almost all CML patients had a specific genetic mutation called the Philadelphia chromosome. It's a translocation between chromosomes 9 and 22.
Wait, they literally swap genetic material, like a
Right.
catastrophic editing error in the DNA.
That's exactly what it is. And that error creates a mutant fusion gene called BCR-ABL.
BCR-ABL, okay.
Right. And this gene produces a mutant protein, a tyrosine kinase, that acts like a biological switch stuck in the on position. It's constantly telling the leukemia cells to multiply over and over.
So it's just spamming the divide command.
Exactly. But once medical science identified that specific mutant protein, they didn't need to carpet bomb the body anymore. They designed a molecule, a drug called imatinib, that acted like a biological key, perfectly shaped to jam that specific mutant lock.
Oh, wow. So it specifically targets that one error.
Yes. It binds to the BCR-ABL protein and just turns the switch off. The cancer cells stop dividing and die, while the healthy cells, which obviously don't have that mutant protein, are largely spared.
That is just stunning. You are targeting the exact corrupted line of code without crashing the rest of the operating system.
One of the greatest medical breakthroughs of our time.
And that shifted CML from a terminal diagnosis to a chronically manageable condition for millions of people. I mean, that's miraculous. But as incredible as targeted therapy is, it relies on the cancer having a specific targetable mutation, doesn't it?
It does, yes. That's the limitation.
So what happens when it doesn't have that specific target? That brings us to immunotherapy, which honestly feels even more like science fiction to me.
Immunotherapy is arguably the most elegant approach to cancer treatment ever conceived. because it utilizes the most sophisticated defense system known to biology, the human immune system itself.
Hacking the body's own defenses.
Exactly. Historically, cancer cells were incredibly adept at evasion. They evolved these mechanisms to express proteins that essentially act as an invisibility cloak. They tell the body's T cells, which are the immune system's apex predators, they tell them, hey, I belong here, don't attack me.
So the immune system just ignores the tumor cells entirely as they multiply. It
Yeah.
doesn't even see the threat.
Exactly. It's completely blind to them. But immunotherapy, specifically treatments like CAR T cell therapy, fundamentally alters that dynamic.
How does CAR T work?
Well, in CAR T, we actually extract the patient's own T cells from their blood. We take them into a laboratory, and we use a viral vector to genetically engineer them.
Wait, a virus?
Yes, a deactivated virus used as a delivery mechanism. We insert a new gene that causes the T cells to express a chimeric antigen receptor.
The CAR in CAR.
Exactly. It's a specialized tracker designed to lock onto a specific antigen found only on the surface of leukemia cells, like CD19.
Wait, let me make sure I have this straight. So you are literally extracting the patient's immune cells, biologically reprogramming them in a lab to recognize the cancer's invisibility cloak, multiplying them by the millions, and then putting them back into the body.
That is exactly what happens. You are infusing the patient with a living drug. It's a highly trained, hyper-aggressive army of their own cells that will now hunt down the leukemia with ruthless precision.
That is mind-blowing. It is a monumental shift from introducing a harsh chemical to attack the body to empowering the body to eradicate the threat itself.
It really is. It changes everything.
When you lay it out like that, the orange ribbon completely changes context for me. It isn't just a symbol of solidarity. It is a banner representing arguably the highest peaks of human biological engineering.
It is a literal representation of hope, fueled by tangible medical breakthroughs.
But, and this is a massive caveat in the literature we reviewed for today's deep dive, these therapies are not magic bullets.
No, they are not. They come with very severe risks.
Right. Things like cytokine release syndrome, where the immune system goes into such overdrive it can actually become fatal. And more importantly, there are cases where the marrow is just too corrupted or the leukemia is just too aggressive, and molecular manipulation simply isn't enough to save the factory.
Right. Sometimes the entire factory has to be razed to the ground and completely rebuilt.
Which brings us to the absolute edge of medical intervention. The hematopoietic stem cell transplant, commonly known as a bone marrow transplant.
Exactly. When chemo, targeted therapy, and immunotherapy fail or just aren't viable, this is the ultimate lifeline.
It's the only remaining option.
Yes. You deliberately and systematically destroy the patient's entire diseased bone marrow and immune system using lethal doses of chemo and radiation.
Lethal doses.
Yes. And then you rescue the patient by infusing healthy stem cells from a donor.
I really want to pause right here and ask you, the listener, to truly internalize the gravity of that. You are intentionally brought to the brink of death. Your immune system is completely eradicated. You have absolutely zero internal defenses left. And your survival is entirely dependent on the biological compatibility of a complete stranger.
It is an act of supreme vulnerability. There's nothing quite like it.
I used to think the matching process was just like a rigorous blood drive, you know? Like you match typo blood with typo blood and you're good to go. But the literature stresses that the genetic matching required for a marrow transplant is exponentially more complex. Why is finding a donor so incredibly difficult?
Well, this raises an important question about genetics. Because we aren't matching blood types. We are matching the very mechanisms of biological identity.
Biological identity. What does that mean exactly?
It relies on human leukocyte antigens, or HLA typing. HLA are proteins, or markers, that are found on most cells in your body. Your immune system uses these exact markers to differentiate between self and non-self.
Okay, so like a highly complex biological barcode.
That's a perfect analogy. If a patient receives stem cells from a donor whose HLA barcode doesn't match their own closely enough, the consequences are catastrophic.
Because the new immune system will wake up, look around, realize it's in a foreign body, and attack the patient.
Exactly. It's a condition called graft versus host disease, or GVHD. The newly grafted immune system literally recognizes the patient's organs, their liver, their skin, their gut, as foreign invaders, and begins to systematically destroy them.
Oh my God. That is terrifying.
It is. So to prevent this, doctors look for a 10-point HLA match. And because these HLA markers are inherited, your highest statistical chance of finding a match is within your own ethnic background.
Because those genetic haplotypes evolved within specific geographic and ancestral populations over thousands of years.
That's exactly right.
Which exposes a terrifying disparity in our current medical system. If you are of Northern European descent, your chances of finding a fully matched donor on the global registry are relatively high, often upwards of 75% or 80%.
Simply because the registries have historically been populated by those specific demographics.
Right. But if you are Black, Hispanic, Asian, or of mixed ethnic background, those odds plummet drastically, sometimes down to 20% or even lower. The genetic diversity of the human population demands an equally diverse donor registry.
Absolutely.
Otherwise, we're quite literally leaving massive swaths of the population without a lifeline based purely on statistical inheritance.
It is a profound issue of medical equity. A lack of diversity on the registry is a structural failure. And what's so frustrating is that the hesitancy to join the registry is largely fueled by deeply entrenched, completely outdated myths.
Yes. Let's talk about this. The cinematic trope of the giant, terrifying needle being hammered into the hip bone while the patient bites down on a leather strap. People are terrified of the donation process because of movies and TV shows.
It's a pervasive myth that actively costs lives. The reality of modern donation is completely different.
Thank goodness.
Right. While traditional marrow extraction from the pelvic bone is still performed in a small minority of cases, and by the way, that is always done under general anesthesia, so the donor feels zero pain during the procedure.
Right, you're asleep.
Yes. But around 80% of donations today are actually done via peripheral blood stem cell, or PBSC, donation.
How does that differ mechanically from the hip extraction?
Well, the donor receives injections of a protein called filgrastim for a few days before the actual donation.
Okay, what does that do?
This stimulates their bone marrow to overproduce stem cells and naturally release them directly into the circulating bloodstream.
Oh, so they just kind of flood out into the veins.
Exactly. Then, on the day of donation, the donor sits in a comfortable chair, maybe watches a movie. Blood is drawn from one arm. It passes through an apheresis machine that centrifuges and filters out those extra stem cells. And then the remaining blood is returned to the donor through their other arm.
So it's remarkably similar to just donating blood plasma.
Very similar. It takes a few hours. You might feel some mild bone ache for a couple days from that filgrastim injection, and then you just go home.
So what does this all mean in the grand scheme of things? It means the barrier to literally saving a human life, to providing the essential raw material to rebuild a complete stranger's immune system, is essentially a few days of mild discomfort and sitting still for an afternoon.
That's it. It is an astonishingly low barrier for an infinitely high reward.
It's a radical act of empathy. And that brings us to the sociological core of the source material we're looking at today. The medicine, the science, the genetics, they are the mechanics. But the human element is what grounds this entire narrative. Because leukemia is not fought in isolation.
No, it can't be. The psychological payload of a leukemia diagnosis is difficult to overstate. Our sources delve deeply into the emotional devastation of it all.
Yeah, the loss of agency.
Exactly. The profound anxiety of waiting for biopsy results, the physical trauma of the treatments themselves, and that terrifying liminal space of just waiting for a donor match. It strips a family down to its core emotional foundations.
And that's exactly why the support infrastructure isn't just a supplementary benefit. It is a clinical necessity. The isolation of a systemic disease requires a massive, interconnected community to counteract it.
Absolutely. Community support is vital. You see it in the walks, the donor drives, the counseling groups.
We see this manifested heavily in survivorship, too. The psychological studies of survivors highlight a really fascinating phenomenon. Many individuals who achieve remission undergo a profound perspective shift.
They do. They don't just return to their pre-diagnosis lives as if nothing happened.
Right. They become fierce, mobilized advocates. They leverage their trauma to generate momentum for research funding, to run those donor drives you mentioned, and to dismantle the myths surrounding HLA matching.
It's a process of meaning-making. When you survive something that statistically should have killed you, there is often a deep psychological imperative to validate that survival through action.
But we also have to address the reality that not everyone survives. And this is where the source material takes a very poignant look at how we process grief and memory.
Right. For the families who have lost loved ones, the orange ribbon transitions. It moves from being a banner of an active fight to a vessel for remembrance.
And the text provides a very objective analysis of how the physical artifacts of memorialization have evolved. Specifically, they highlight organizations like the Funeral Program Site. Now, looking at this analytically, it's fascinating how bespoke memorialization serves a psychological function right here on a Funeral Channel Network deep
Yeah,
dive.
it really is.
They offer customizable orange ribbons, allowing families to imprint specific names, dates, or personal mantras onto the fabric itself.
And from a sociological standpoint, it's a brilliant mechanism for localized grief.
Localized grief, explain that.
Well, abstract grief mourning the victims of leukemia is cognitively difficult to sustain. It's too broad.
Mhm.
But specific, localized grief mourning Michael, who fought for 3 years, that is visceral.
Oh, absolutely. It gives the grief a face.
Right. By customizing the awareness ribbon, families are taking a universal symbol of a global medical struggle and anchoring it to a highly specific human narrative.
It prevents the individual from being swallowed by the statistics. When you wear a personalized ribbon at a celebration of life or a community awareness walk, you are engaging in a very modern form of public mourning.
Which is a huge shift. Historically, grief was heavily privatized. You mourned behind closed doors.
Yes, very stoic. But this synthesis of memorialization and advocacy allows families to transmute their deepest pain into forward momentum. They are stating, unequivocally, this person's life had weight, their struggle was real, and we are going to use their specific memory as the fuel to fund the research and find the donors that will prevent another family from experiencing this exact void.
It ensures the emotional energy of the loss isn't just dissipated, but directed. The customized ribbon becomes a dual-purpose artifact. It looks backward to honor a unique life, and it looks forward to demand systemic medical change. It's a profound testament to human resilience.
It really is an entire ecosystem of determination. And as we pull back and look at the sheer scope of what we've unpacked today, it's awe-inspiring. We've traced the insidious nature of a disease that corrupts the body's most fundamental biological algorithms.
Right, from the bone marrow out.
We've broken down the staggering intellectual achievements of targeted inhibitors and chimeric antigen receptors that are literally rewriting the boundaries of pharmacology.
The science is just incredible.
We've confronted the stark statistical realities of HLA matching and the critical life or death need to diversify our global donor registries. And we've explored the intricate psychological mechanisms we use to survive the trauma, to advocate for the living, and to beautifully, specifically memorialize those we've lost.
It is a narrative defined by relentless complexity, but driven entirely by the human refusal to surrender. And I actually want to leave you, the listener, with a final thought to mull over.
Please do.
Right now, in this current moment, the orange ribbon is a battle standard. It represents a desperate, ongoing struggle for critical resources, for molecular breakthroughs, and for genetic matches. But I want you to project forward. Imagine a future where, because enough people took the simple step to swab their cheek and join the registry, and because enough collective capital was poured into unlocking the immune system, the orange ribbon transitions permanently.
Wow.
Imagine it moving from a symbol of an active war to a historical marker, a piece of fabric that future generations look at not with anxiety, but with reverence, as a symbol of a systemic disease we fully conquered through deliberate collective human action. Knowing how accessible modern stem cell donation actually is, what small, actionable step could you take this week to help pull that future into the present?
That is exactly the kind of question that turns awareness into action. We want to thank you for taking this deep dive with us today on the Funeral Channel Network, for engaging with the heavy science and the profound human stories behind the orange ribbon. Keep questioning the systems around you, keep looking for ways to tip the scales, and above all, stay curious.